This is a lesson on input-output machines or input-output tables. Before watching the recording, please make sure that you have a graph sheet of paper with you or your math journal, along with a ruler, a pencil, and an eraser. So if you need to pause the recording to get those items, please do so now. I'm going to move on though, and now a copy of this Google slide presentation is also being uploaded onto Google Classroom for your reference too. Just make sure that you're writing things down as I write them down in the video, and remember to pause the recording if you need to catch up or if I'm going too fast. And also replay any parts as you need to review. Now, talking about input-output tables, you may have discussed this question in class already. So you were asked to think about situations where you would give an input in order to get a specific output. So one example could be when you're using a calculator. You don't have to write this part down yet, but just getting you to think about a situation. So if you think about a calculator, you input certain numbers and operations in order to get the answer in a calculator, which is the output. You can also think of Google as a Google search. So if you want to search something up on Google, for example, you enter in the search terms in Google to get the specific output, meaning specific websites or resources that you need. So those are two examples, again, where you're giving an input in order to get a specific output. Now, moving on to math, though, I'm just going to skip to the next slide here. This is applicable in math when we look at patterns and determining patterns of numbers, and also figuring out what's going on with patterns of numbers in a t-table. And when we move into algebra later, and also when you move into algebra later on, as you go through higher levels of math, this is a really important principle of algebra, is being able to solve and determine patterns from a t-table, or what we're going to call right now input-output tables. So we're going to go through a few examples on this video. So like I said, pause it if you need to catch up, or if I'm going too quickly. Replay certain parts if you need to review a certain concept again. So I really encourage you to do that for this video, and that you're learning at your own pace. Now, we'll use these questions as a checklist for ourselves. So number one, this is where you want to pause the video now and set up the t-table in your journals or on a graph sheet of paper similar to the one above. But what I'd like you to do is extend it for the input numbers to 6, like I've done up here. Okay, so again, pause the recording now and do number 1 and number 2 if you can. Okay. Complete the rest of the t-table based on the pattern. So what do you think the rest of the output numbers will be based on the 3 output numbers you have of 9, 10, and 11? So follow the pattern. Pause the recording and go ahead and do that. Now, I'm going to move on. So I've set up the t-table over here on the side. I've extended it for input numbers up to 6. I'm looking at the output numbers. If I know the output, it looks like it's increasing. It looks like it's increasing by 1 every time, and you're starting at 9. Well, I can assume that probably if an input is 4, the output is 12, and then 13, and then 14. Okay. Now, so we've done number 1 and we've done number 2. Now we have to formalize what the pattern is in this first example. Okay, let's look at number 3 now. What is the pattern among the input numbers? I'm going to use this in a different color here. So I'm going to go to, let's use green here. Okay, so I look at the pattern amongst the input numbers, and I can see that you're starting at 1 and you're adding 1 every time. Okay, so that's how you describe the pattern among the input numbers. So start at 1, and you can jot this down. Then add 1 each time, because you'll be asked to describe the pattern among the input numbers. Okay, that's the input. Now the output, I'll color code in purple here. So if I look at the output numbers here, so what is the pattern among the output numbers? So we're on number 4 right now. Okay, so it looks like you're starting at 9 and you're adding 1 each time. So you're adding 1, you're adding 1, and you're adding 1. So what is the pattern among the output numbers? You start at 9, then you add 1 each time. However, though, you need to figure out what the rule is from the input to the output. And let's do this in blue here. So what am I doing to the input number in order to get to the output? Because that's the whole point is, remember, we're going back to that guiding question. Where would you give an input in order to get a specific output? We've determined the pattern amongst the input numbers and amongst the output numbers, but we haven't figured out what's going on from the input to get to the output. Okay, so there's a few things that you can do here. Let's just look at what's happening here, because in this case, it looks like you only need one operation to get from the input to the output. Now, in later examples, I'll tell you to look at the pattern amongst the output numbers or look at the pattern amongst the input numbers, but it doesn't really help you because both sides are increasing by 1. So all you have to do is, well, what are you doing to get from 1 to 9? What are you doing to get from 2 to 10? What are you doing to get from 3 to 11? Is there a common difference? So pause the recording right now, or maybe you know already. Is there a common difference between 1 and 9, 2 and 10, 3, 11, and 4 and 12? Well, if you've had a chance to think about it, if you know, the difference between 1 and 9 is that you add 8, right? The difference between 2 and 10 is that you add 8. The difference between 3 and 11 is that you add 8. And the difference between 4 and 12 is that you add 8. So in this case, this is an example of a one-step pattern rule because you only need one operation to get from the input to the output. So therefore, if we answer number 5, what is the pattern rule to get from the input to the output numbers? How did you figure it out? Okay, well, we figured it out by finding the difference between, we found the difference, so write this down. Between the input and output numbers. What is the pattern rule to get from the input to the output numbers? Well, the pattern rule is you add 8 to the input to get the output. Because we found that common difference of 8. This is how you would express and communicate the different patterns amongst the input, the output, and what is the pattern rule to get from the input to the output numbers. Okay, so that's example number 1. So example number 1 was a one-step pattern rule. However, don't always expect one-step pattern rules. More often than not, you will be getting two-step pattern rules, which is what we'll progress to in the next few examples. Okay, example number 2. So this time we have a visual here that's been set up. So we've got an actual picture here, and this is taken from visualpatterns.org. So similar to the previous example, pause the recording, set up the t-table similar to the one above, complete the rest of the t-table based on the pattern and extend it for input numbers 1 to 6. So pause the recording now and do that in your math journal or on a graph sheet of paper, and then replay the recording once you're ready to continue. I am going to continue here, and what I'm going to do is I'm going to do the same thing as I did above, and I'm going to just do the input here and do the output. I'm just going to make sure I know my colors here. So green was input, and then the output was purple. and then input and output was blue. Okay, just so that we're being consistent here. I'm just going to recopy this. So 1, 2, and 3. If you want to skip through this part, you can, and then just go to the part where I've extended the t-table. 1, 3, and 5. So I said to extend the t-table for input numbers to 6, 4, 5, and 6. And then now, if I'm looking at the output numbers here, I can see you're starting at 1 and you're adding 2 each time. So 1 plus 2 is 3, 3 plus 2 is 5. So we know that 5 plus 2 is 7, 7 plus 2 is 9, and 9 plus 2 is 11. So the rest of the output numbers, it looks like, will be 7, 9, and 11 for the corresponding inputs 4, 5, and 6. Okay, so we've done numbers 1 and 2. Now, what is the pattern among the input numbers? It looks like it's very similar to the previous example. It looks like you're adding 1 each time and you're starting at 1. Notice I'm also going to describe the number that I've started off with. So I start at 1 and add 1 each time. You may wonder, why are we looking at the pattern amongst the input and the output numbers? In this example, particularly, the pattern amongst the output numbers will help you figure out what the pattern rule is from the input to the output. Okay, now let's look at the pattern among the output numbers. So I said earlier that it looks like we're starting at 1 and we're adding 2 each time. So I'm just going to indicate that on the t-table too. And then we're starting at 1 and then you're adding 2 each time. That is the pattern amongst the output numbers. Okay, so we've done. So these are the steps that you need to follow when you're figuring out the pattern rule from the input to the output. These will work every time. Now, we're going to look at number 5. What is the pattern rule to get from the input to the output? Okay, now if you look at the hint here, look at the difference between the output numbers. And now this time I'm going to draw on this t-table here. Okay, maybe it's not as obvious with the input being 1 and the output being 1. But let's maybe look at the input of 3 and the output of 5. Well, if I look at the difference between 3 and 5, it's 2. If I look at the difference between 2 and 3, it's 1. And if I look at the difference between 1 and 1, well, it's 0. So that's not very helpful. So now we're going to look at something that they have in common here. If we look at the output numbers, which I'm going to circle here. Okay, now remember we said the pattern amongst the output was that it started at 1 and added 2 each time. So it increases by 2 each time. Well, I'm thinking that perhaps that's a number that you need to multiply. And whenever you're coming up with a 2-step pattern rule, which this example is, the first operation in a 2-step pattern rule has to be multiplication or division. And I'll reiterate that point later as well. Okay, so I'm looking at, and I'm going to start with the 3 and 5 example because it will be more obvious. If we multiplied 3 times 2, we get 6, right? How do we get from 6 to 5? Well, how do we get from 6 to 5? If you subtract 1, you get 5, right? Okay, let's try it with the input of 2. If you multiplied the input number by 2, you get 2 times 2, which is 4. How do you get from 4 to 3? Well, you subtract 1 to get 3. Okay, well, let's try that with the input of 1. If we multiplied the input number by 2, we get 1 times 2, which is 2. How do we get from 2 to 1? Well, we subtract 1 to get an output of 1. It looks like then that the 2-step pattern rule is that you multiply the input number by 2, which is the same as what the difference is of the output numbers or the pattern, and you subtract 1. Well, let's try that for the next one, just in case. Remember we said if the input was 4, the output was 7, right? Okay, so again, same thing. We're going to multiply 4 times 2, which is 8. How do we get from 8 to 7? We subtract 1 to get 7. That's how we figure out what the pattern rule is here. I'm just going to highlight this. So the pattern rule to get from the input to the output in this case is we multiply the input by 2 and we subtract 1 to get the output. Look at what we did for each example. If we did 1 times 2, we got 2. How do we get from 2 to the output of 1? We subtract 1. So the second one, 2 times 2 is 4. How do we get from 4 to 3? We subtract 1. 3 times 2, which is 6. How do we get from 6 to 5? We subtract 1. 4 times 2, which is 8. How do we get from 8 to 7? We subtract 1. So if we answer question number 5, what is the pattern rule to get from the input to the output? Multiply the input number by 2, then subtract 1 to get the output. This is how you communicate what the pattern rule is. Subtract 1 to get the output. How did we figure it out? We looked at the difference. We looked at the pattern among the output numbers to help us. To help us figure out what you're multiplying by. Okay, so that's example number 2. Now, I'm going to move on to example number 3. So I invite you again to pause the recording and copy down the T table listed here in your journal. So similar to the other 2 examples, you're going to set it up in your journal or your engraphed sheet of paper, complete the rest of the T table based on the pattern, and extend it for input numbers to 6. So pause the recording now and go ahead and set that up in your journals. I'm going to continue here. So, okay, there's a little bit of an overlap here, so I'll do this. Input and output. Now, because we've done, I'll tell you again that this example is also a 2-step pattern rule, similar to example 2. So if you want to actually, if you're feeling confident enough, or you're feeling like you want to try this on your own, pause the entire recording right now and try to figure out steps 3 to 5 on your own before you replay the recording. If you still want some guidance in figuring out this question, so keep watching the video. But again, if you want to pause the recording, figure it out yourself, and then replay it to check your answer, I invite you to do that now. So I'm going to extend it up to 6, and then 6, 9, and 12. Okay, here we go. It looks like it's increasing by 3 each time, and you're starting at 6. So I can assume that 12 plus 3, we've got 15. 15 plus 3, we've got 18. 18 plus 3, we've got 21. Okay. Now, pattern among the input. I believe input was green. Okay, so in this case, it's also like the other 2 examples, you're increasing by 1 every time. So start at 1, add 1 each time. Is that what I said? Yeah, add 1 each time. Okay, so we've done step 3. Step 4, what is the pattern amongst the output numbers? So it looks like we're starting at 6 and we add 3 each time. Always indicate this just as a guide to know that you've done the checklist, right? So you're going to start at 6 for the output, and then you're going to add 3 each time. So you can already tell that, again, this pattern amongst the output numbers will help us in this particular question for the next step, number 5, because you have to figure out What are you doing to get from the input to the output? Because again, we want to always be able to predict what the output is based on what the input number is, because that's the pattern we're trying to figure out. Now, I should mention too, and I forgot to do this in the previous example, that this is related to this pattern here. If you look at the input number, it says figure number here in brackets. Figure number means this is figure number 1 or picture number 1. This is picture number 2, and this is picture number 3. Sorry, I forgot to include that on the previous example. Output number says number of blocks here. This means number of, let's say, suns. They look like suns, but I'm not sure. Or, oh, no, they're snowflakes. Sorry. It says snowflakes there. Number of snowflakes. So this means the number of snowflakes in each figure or each picture. So if we look, if in figure number 1 or picture number 1, we've got 6 snowflakes. 1, 2, 3, 4, 5, 6. In figure number 2, the number of snowflakes we have should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And in figure number 3 or picture number 3, there should be 12 snowflakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how that works. My apologies. I should have pointed that out to you there. Okay, so in any case, what is the pattern rule to get from the input to the output? Okay, so again, this hint here, we're going to look at the difference between the output numbers. Now, most likely, we're going to multiply, and then we're going to do another operation as well. So we know that the difference between these are not all the same, right? So the difference between 1 and 6 is 5. The difference between 2 and 9 is 7. And the difference between 3 and 12 is 9. So the difference is there's no consistency. So what we're going to do is we're going to take that pattern amongst the output numbers. So we're going to use that as a number that we're going to multiply by. So if we did 1 times 3, we get 3, right? How do we get from 3 to 6? We add 3, okay? So ask yourself the same thing. If we had the input number of 2 and we multiplied that 3, 2 times 3 is 6, right? How do we get from 6 to the output of 9? We also add 3. Oops. We also add 3. And then same thing. If we took the input number of 3, we multiplied it by 3. 3 times 3 is 9. How do we get from 9 to 12? We add 3. Okay, it looks like our pattern rule to get from the input to the output in this case is you multiply the input by 3 and you add 3 each time to get to the output. Let's try it for 4 just to make sure. So if the input or figure number was 4, we said the output has to be 15. Well, 4 times 3 is 12. How do we get from 12 to 15? You add 3. Usually for figuring this out, if you do the first 3, then you know it's probably the correct pattern rule if the math works every time. So what is a pattern rule to get from the input to the output numbers? Okay, so what we're doing is we multiply the input number by 3, then add 3 to get the output numbers. To add 3 to get the output. Okay, how did you figure it out? Again, we looked at the difference. We looked at the difference among the output numbers to help us. Okay, now I'm going to point out one other thing too. In a future lesson, you'll be learning something called order of operations. And what I want you to notice is that whenever you have a two-step pattern rule, that first operation in a two-step pattern rule is going to have to be multiplication or division. So if you look at example number 3, our first operation in a two-step pattern rule was multiplication. If you look at example number 2, our first operation in a two-step pattern rule is multiplication, because it has to follow something called order of operations, where multiplication and division have to come first before addition and subtraction. Now, example 4 will follow the same pattern. However, what you'll notice is something different. Okay, so same thing. Pause the recording and copy down the t-table. And actually this time you're just going to copy it down as is. I'm actually not asking you to extend the t-table this time. So just copy down the input and the output as it is here. So pause it if you need to do that now, and then replay it when you're ready to continue. Now, this time we're going to go, so we've already done number 1. We're going to look at number 2. What is the pattern among the input numbers? Okay, so input numbers. Now, if you notice, there's a difference with these input numbers as opposed to the other examples up above. If you look at the other input numbers, we only have a difference of 1, or it's starting at 1, adding 1 each time in example number 3 and number 4. Example number 3 and number 2. If you notice this time, the input number is starting at 10. And what we're doing is, and I'll just do it on this side here, we're adding 10 each time. Okay, so to get from 10 to 20, you add 10. To get from 20 to 30, you add 10. And if you get from 30 to 40, you add 10. So the pattern among the input numbers is you start at 10 and add 10 each time. Now, look at the hint this time. This time you're going to look at the pattern among the input numbers to help you for number 4. Before we get to that, let's deal with number 3 first. What is the pattern among the output numbers? Okay, so this time the output numbers, the patterns doesn't look like it's going to be super helpful, but we'll indicate that anyways here. Looks like you start at 6 and you add 1 each time. Now this example is slightly different, because if you look at number 4, we're going to say, what is the pattern rule to get from the input to the output numbers? Well, in this case, what you should notice is that the input is larger than the output here. So if you look at the input of 10, it's larger than the input of 6, significantly larger. If you look at the input of 20, it's significantly larger than the output of 7. If you look at the input of 30, significantly larger than the output of 8. It doesn't follow that same sort of pattern as we've looked in example 3 and 4, where the input has been smaller than the output. If you look at, sorry, I keep saying 3 and 4, 3 and 2. If you look at the input here in example 2 is slightly smaller than the output. In this case, though, it's the opposite. Okay, so if I'm thinking that, I'm thinking there's maybe some subtraction, but also maybe some division happening. Now, this time we're looking at the pattern among the input numbers to help us figure out what the two-step pattern rule is. So would it make sense that we're multiplying the input to get to the output? Maybe not. I mean, we need to use these differences of 10 to help us. But maybe what we need to do is we need to divide by 10, because again, the input is significantly bigger than the output. So what happens if we did that? Okay, what would happen if we did that? If we did 10 divided by 10, we would get 1. How do you get from 1 to 6? Maybe not subtraction this time, maybe we need to add. We need to add 5 to get 6. Okay, let's look at the second one. If the input was 20, we divided it by 10, which is the difference here. 20 divided by 10 would give us 2. How do we get from 2 to 7? We add 5. Okay, similarly with 30, if we did 30 divided by 10, we get 3. Again, how do we get from 3 to 8? We add 5. Let's try for kicks the last one. 40 divided by 10 is 4. How do we get from 4 to 9? We add 5. So in this case, because the input is significantly larger than the output, it's good to try the division. But The hint here was because that there is some sort of pattern going on with the input numbers here, it was going to help you more in determining what the pattern rule here is. So we know that the pattern rule is that we're dividing the input by 10 and we're adding 5 each time to get the output. That's the two-step pattern rule here. And remember what I was saying before is that first operation in a two-step pattern rule has to be multiplication or division. Let's summarize this and then we'll get to the last slide in a bit here. Okay, so the pattern rule to get from the input to the output is we divide the input by 10 to get the output. Oops, sorry. Okay, I forgot the other step. We divide the input by 10, then add 5 to get the output. How did you figure it out? This time we looked at the pattern amongst the input numbers to help us. We looked at the pattern among the input numbers to help us. Okay, now I'm going to skip over example 5 because I'm just going to move on to the last slide, which is summarizing this. Okay, so here are some steps or things to figure out when you're trying to determine the pattern rule for an input-output table, okay? So the first step is make sure that the input and output numbers are in numerical order. Sometimes they're not in order, but arrange them in order. So if it's a matter of rewriting your t-table, go ahead and do that. So you're going to do steps 2 and 3 all the time. And you don't always have to write out the pattern or the difference among the input and the output, but it's helpful. If you look at step number 4, you're going to follow the process in the example below. Use the pattern to either multiply or divide the input number, then figure out the difference to get the output number. Sometimes you're adding and sometimes you're subtracting for that second step, okay? So if you look at this example here, we can determine that the difference between the output numbers is 2. You're starting at 1 and you're adding 2 each time. I think this was example 2 in the slides. So if we did input number times 2 is 2, how do we get from 2 to 1? We subtract 1. If the input number was 2 and we multiplied it by 2, 2 times 2 is 4. How do we get from 4 to 3? We subtract 1. If the input number was 3, we multiplied that by 2, we get 6. How do we get from 6 to 5? We subtract 1. So that's the steps that you would follow in determining the pattern rule. Remember that first operation could also divide as well, but you always have multiplying or dividing first before adding or subtracting. If the input numbers are smaller than the output numbers, then the first operation is probably multiplication. This was the case in examples 2 and 3, right? If the input numbers are larger than the output numbers, then the first operation is probably division. This was example 4 above, right? And this was examples 2 and 3. Okay. Remember that multiplication and division are before addition and subtraction in a two-step rule. So I would jot this down in your journals or on your graph sheet of paper. So you always have multiplication and division before addition and subtraction in a two-step rule. Always, always, always that is the case, okay? Because we have to follow something called the order of operations. So these are the steps that will help you determine the pattern rule for an input-output table when you're trying to figure out, again, when you have a specific input number, what is the output number? You should be able to figure that out based on the rule.